This is Algebra 2, Lesson 9.5, Histograms and Percentiles. So our first definition is histogram. A histogram is a specialized bar graph, but it's different from a bar graph because unlike having just categories on the bottom, it has ranges or intervals of data on the bottom. So, you can see this example right here. This bar includes all the data between 30 and 35, and so that would be that there are 9 data points between 30 and 35. And this one has all the data between 35 and 40, and so there are 6 data points between 35 and 40. So it's a specialized bar graph that has intervals or a range of numbers on the x-axis. The bin width is the special name for the size of the interval. So for example, this graph right here has a bin width of 5 because every one of these is 5 units. This histogram in example B actually has a bin width of 2.5 because every one of these bars is 2.5 percentage units wide. And then percentile rank is a calculation where you do the number lower than the given number divided by the total number of numbers. And we'll do an example of that down lower, and I think it'll make a little more sense. So the first example here says both graphs A and B were constructed from the same data set. How many metropolitan areas are included in the data? So if we look at this graph right here, between 25 and 30 I had 1 metro area. Between 30 and 35 I have 9. Here I have 6. Here I have 1, 6, 1, and 1. So how many are included in the data would be to add those up. 1 plus 9 plus 6 plus 1 plus 6 plus 1 plus 1. We have 25 included in the data. What is the range of the data? We can't actually explicitly calculate that because we need to know the maximum value and we need to know the minimum value. We can get an approximate answer. It would be approximately 85 minus 25, so about 60. But since we don't know that this value is 85, it could be 81, 82, 83, I'm just estimating that it's 85. And we don't know that the minimum is 25, I'm just estimating that it's 25, so it's about 60. What is the bin width of each graph? Graph A, I had already said that was 5 because the bars are 5 units wide. And in graph B, they were 2.5. Next question, why are the columns shorter in graph B? If you look at this bar right here that ranges from 30 to 35, we have 9 units in there. If I look at this one down here, from 30 to 35, here I have 6 and here I have 3. So this 6 and this 3 put together make the 9, and that's why these bars are shorter, because it takes 2 bars down here to make up to 1 bar up here. I don't want to write that out on the mouse, it's hard, but it takes 2 bars in graph B to make up 1 bar in graph A. Letter E says describe how each graph illustrates clusters and gaps. So we have a cluster probably from about 25 to 50. Cluster 25 to 50. And then we have a gap here from 50 to 65. And there's another gap here from 70 to 80. And so what the histogram shows is that we have a bunch of metro areas between 25 and 50, but they're more sparse after that. We do have one here and one here, but it's still a big gap there. And this one right here, there's a little gap right here in this graph. So depending on how we set up the bin width, we can kind of skew the data to make it look however we want to look. F says how many metropolitan areas grew between 35 and 40%? So between 35 and 40 here, that would be 6. We can tell that on the original graph by looking at just that bar, on graph B, we'd have to add together these two to get from 35 to 40, but 3 and 3 gives me the same answer of 6. And the last question on here says, what percentage of these metro areas had population changes less than 35%? So if I find 35% is right here, let me erase this. 35% is right here, and so less than that value would be the 9 and the 1, so that would be 10. You can get the same information on the bottom graph, but you'd have to add more. You'd have to add 3 plus 6 plus 1, but you'd still get the same answer of 10. Okay, example B says, consider the histogram at right, approximate the percentile rank of 60. So 60 is right here. Now, the definition I gave above said the number lower than, then divided by the total number. So if I want the percentile rank of 60, I need the number lower than 60 divided by the total number. So let's add these up. I have 2, 4, 5, 9, 4, 4, 3, 3, 2, 1. So this bunch is 37 plus 2 more and 1 more means that my total is 40. So my percentile rank would be 37 divided by 40, which gives me 0.925. Now I want to take that decimal and turn it into a percent. So move your decimal point 2 places, or you can multiply by 100, and that's about 93%. We'll do the same with the percentage of data values between 20 and 50. So 20 is here, 50 is here, that is 5 and 9 and 4 and 4 and 3 and 3 gives me 28 between 20 and 50 out of the total 40, and we will turn that into a percentage. 28 out of 40 gives me 0.7 times by 100 will turn that decimal into 70%. So when it says percentile, you just do the number lower than the given number. When it says percentage between, you'd count between the two numbers it gives you. And that's it for the notes. So you have the rest to do the exercises. Good luck.